This video series will cover circuits. First, let's talk about electric current. Electric current is the rate of flow of electric charges, those charge carriers, through space. More specifically, it is defined as the amount of charge that flows past a location in a material per unit time. The letter I is the symbol for current. I is defined as the change in charge divided by the change in time. Delta Q is the amount of charge that passes by that point. Delta T is the time it takes to flow past the location. The current depends on the type of material and the electric potential difference, or the voltage across it. A good analogy to help understand electric current is to consider water flow. The flow of water molecules is similar to the flow of electrons, the charge carriers, in a wire. Water flow depends on the pressure exerted on the molecules, either by a pump or by a height difference, such as water falling off a cliff. Electric current depends on the pressure exerted by the electric potential difference. The greater the electric potential difference, the greater the electric current. The current, I equals delta Q over delta T, has the units of coulombs per second. We can rewrite these units as amperes. We use a capital A to represent amperes, which is a coulomb per second. Oftentimes we call this an amp. We know that if an electric potential difference is applied to a wire, charges will flow from high to low potential, which is called a current. However, due to a convention set by Benjamin Franklin, current in a wire is defined as the movement of positive charges, not the electrons, which are actually the ones moving. We call this conventional current. Benjamin Franklin didn't do this to confuse future generations of electrical engineers and students. It was already known that electrical phenomena came in two flavors, attractive and repulsive. Franklin was the person who explained them as distinct positive and negative charges. He arbitrarily assigned a positive charge to a glass rod that had been rubbed with silk. He could just as easily have called it negative. It was a 50-50 chance. The glass rod was later found to have a shortage of electrons. They were transferred to the silk. So if the glass rod is grounded, the electrons will flow from the ground to the rod. The problem comes in how electric potential is defined. Charge carriers will be driven from high to low potential, from positive to negative. For this to occur in the glass rod ground system, the conventional current will flow from the rod to the ground, opposite the direction of the movement of electrons. To summarize, conventional electric current is defined as the movement of positive charge. In wires, it is opposite to the direction of the electron movement. However, in the case of a particle accelerator, where electrons are stripped off of an atom, resulting in a positively charged ion, which is then accelerated to strike a target, the direction of the conventional current is the same as the direction of the positive ions. An electric circuit is an external path that charges can follow between two terminals using a conducting material. For a charge to flow, the path must be complete and unbroken. An example of a conductor used to form a circuit is copper wire. Continuing the water analogy, one can think of a wire as a pipe in which the charge is to move through. We also call this diagram a schematic. 12 coulombs of charge passes a location in a circuit in 10 seconds. What is the current passing through the point or past the point? Go ahead and pause the video to solve this problem. Okay, so let's check your answer. You should have used that the current is equal to delta Q over delta T, which is 10 coulombs divided by 10 seconds, which gives us 1.2 amps. A circuit has 3 amps of current. How long does it take 45 coulombs of charge to travel through the circuit? Go ahead and pause the video now and answer. Okay, so let's see if you have the correct answer. You should have solved for the time t. I is equal to delta Q over delta T. Solving for T, it's delta Q over I. 45 coulombs divided by 3 amperes, or 3 amps, is equal to 15 seconds. A circuit has 2.5 amps of current. How much charge travels through the circuit after 4 seconds? Go ahead and pause the video. Okay, so let's see what you did and how you did on this one. I is equal to delta Q over delta T. Solving for Q, I get I delta T. Substituting in the numbers, we end up with 10 coulombs. Let's talk about batteries. Each battery has 2 terminals, which are conductors. The terminals are used to connect an external circuit, allowing the movement of charge. Batteries convert chemical energy to electrical energy, which maintains the potential difference. The chemical reaction acts like an escalator, carrying charge up to a higher voltage. If you go ahead and click on I'm going to click on this link. What you'll end up with is getting the battery voltage thing. If you open this up, this is your the simulation from the FET people. So this link right here will be available in Edmodo. Okay, so I just wanted to show you that that's what would happen if you clicked on that link, and I will make that available in Edmodo. Okay, so let's review the basic circuits. The circuit cannot have any gaps. The bulb had to be between the wire and the terminal. A voltage difference is needed to make the bulb light. The bulb still lights regardless of which side the battery you place it on. As you watch this video, write your observations and answer the questions below. What is going on in the circuit? What is the role of the battery? How are circuits different? How are they similar? Now, I'm going to provide you with this link. So just so you know, this is the video. It's the series and parallel circuits video that's already attached to your assignment for Edmodo. The battery pushes current through the circuit. A battery acts like a pump, pushing charge through the circuit. It is the circuit's energy source. Charges do not experience an external force unless there is a difference in electric potential, what we call voltage. Therefore, batteries have a potential difference between their terminals. The positive terminal is at a higher voltage than the negative terminal. How will voltage affect current? Okay, so again, you're going to click on the link that's provided on the assignment. This is the video clip that you will see. It will say current and voltage. Okay, once you watch that video clip, you should be able to answer the question, how will voltage affect current? In the next video segment, we're going to talk about conductors.